Section 5.2, we're looking at more properties of exponents. And so, first thing we look at is power rule for exponents. We know that b to the m to the n is equal to b to the m times n. And basically it's just the idea that if we've got 2 squared cubed, we're thinking that is 2 squared times 2 squared times 2 squared equals 2 to the 2 plus 2 plus 2, which is 2 to the 6th. And so we wind up getting 2, 4, 8, 16, 2, 4, 8, 16, 32, 64. And unsurprisingly, we notice that if we took 4 cubed, we would get 64. So this comes in handy if we're looking at things like x squared to the 4th. We notice that we'd rather not have to write x squared times x squared times x squared times x squared equals x to the 2 plus 2 plus 2 plus 2 equals x to the 8th, when all we have to do is just say x to the 2 times 4 is x to the 8th. That's especially handy if we have something like y to the 5th to the 8th, where we'd really rather just write y to the 5 times 8 equals y to the 40th. Trying to write it out in expanded form is not at all pleasant. So then if we tried looking at something in the form ab to the n, we remember that we're thinking of that as a times b to the nth power, and we know that's going to be a to the n times b to the n. And again, just practicality. If we have 2x to the 4th, we know that would be 2x times 2x times 2x times 2x would give us 2 to the 4th x to the 4th, and so it's easy to just write down 2 to the 4th x to the 4th. And if we wanted to, we could write the 2 to the 4th as being 16. So we get 16x to the 4th. And similarly, we notice that if we have a divided by b to the nth power, that's going to be a to the n divided by b to the n. And same idea. If we had 2/3 cubed, that's 2/3 times 2/3 times 2/3, winds up giving us 2 to the 3rd divided by 3 to the 3rd, or 8/27. So if we're looking at something like x divided by 2y to the 4th, we can mix and match a little bit. We notice that's going to be x to the 4th divided by 2y to the 4th, and then we can use our property for products to say that's going to be x to the 4th divided by 2 to the 4th y to the 4th, which gives us x to the 4th divided by 16y to the 4th. So, nice and neat. So what we'll sometimes come across is having to move all of that together. If we tried looking at something like 3x squared y cubed to the 4th, we notice now we have to mix those rules about products and our rules about the exponent properties to say 3 to the 4th, x squared to the 4th, y cubed to the 4th, and that would give us 81 x to the 8th, y to the 12th. We're just noticing that we're taking 2 times 4 to get 8 for the exponent of x, and 3 times 4 to get 12 for the exponent on that y. And again, just the idea that if we take x squared times x squared times x squared times x squared, we get x to the 8th. If we take y to the 4th times y to the 4th, y cubed times y cubed times y cubed times y cubed, we get y to the 3 plus 3 plus 3 plus 3, gives y to the 12th. So let's try one more example of that. If we had something like 5m squared n cubed divided by, let's make it 3m squared. That's boring. We'll do n to the 4th z squared to the 5th. We notice that we can actually do a little bit of simplification on the front end. We notice n cubed divided by n to the 4th. We can write as 5m squared divided by 3n z squared. We notice that 3 of the n's divide out, and that's to the 5th power. And then we can write that as 5 to the 5th, m squared to the 5th, 3 to the 5th, n to the 5th, z squared to the 5th. And so that's going to give us 5 to the 5th gives us 3,125. M to the 10th divided by 243. N to the 5th, z to the 10th. You'll notice that you won't get numbers that are quite that big. Let's look at one that's a little smaller. So if we had something like, let's try 4x squared y divided by 2xy cubed, and we squared it. This is a little more manageable. We notice that 4 divided by 2 is going to give us 2. X squared divided by x gives us x. Y divided by y cubed gives us a y squared in the denominator. And if we square that, we're going to get 4x squared divided by our y squared, which gives us 4x squared divided by y to the 4th. And we notice it's always easier to simplify first if we can. You notice our alternative would have been to write that as 16 x to the 4th y squared divided by 4x squared y to the 6th, which it gives us much bigger numbers. It still simplifies to the same thing, 4x squared divided by y to the 4th, but it makes more work for us. So we like to avoid that if we can.